This video is about solving and graphing one-step and multi-step inequalities and writing inequalities that represent real-life situations. So yesterday we started to talk about the inequality symbols, and we had less than, which is an arrow pointing to the left. We had greater than, which is an arrow pointing to the right. We have less than or equal to, which is pointing to the left and has a bar underneath it, and greater than or equal to, which is pointing to the right with a bar under it. There are two more synonyms for less than or equal to. We have no more than, is no more than, and is at most are also synonyms for is less than or equal to. We also have two synonyms for greater than, which is no less than and is at least. So we're going to use these phrases to look at sentences and be able to write an inequality to represent them. So first we're going to start out with just the variable. So we have x is at most 25. So at most means that's the highest number it can be. So we would have x is less than or equal to 25. Number two, y is no less than negative 17. That means that's the bottom number that y could be, but it could be anything bigger. So we would have the y is greater than or equal to negative 17. Number three, z is less than 0. So we have z, an arrow pointing to the left, and 0. M is greater than or equal to 5. So we have M and then the greater than or equal to sign. 5. K is no more than 76. So we have K to be no more than. That means 76 is the maximum height. So we would have K is less than or equal to 76. Number 6. P is at least 103. So at least is our phrase there, and that's the lowest number it could be. So we have P is greater than or equal to 103. Number 7, student council wants to raise at least $1,000. So we're looking for that key phrase of at least, and then we can pick any variable we want. So I'm going to say M at least means it's greater than or equal to $1,000. Number 8, a car can hold at most 5 people. So we're going to say P at most is our key phrase, which means 5 people can fit in or less. So we would have a less than or equal to 5. Number 9, the football team must win at least 6 games in order to guarantee a playoff spot. So we have at least again. So we're going to say G is greater than or equal to 6. Number 10, a child must be at least 56 inches tall in order to go on the water slide. So at least is our minimum height for them to be able to go on the water slide. So we have height is greater than or equal to 56. So let's also look at determining if x is a solution, which we talked about a little bit yesterday. So when you're given an inequality, you're going to take the value that they give you for x and substitute in for x. So we have negative 7 is greater than negative 4. Does that make sense? No, because negative 7 is actually less than, so is it a solution? No. Number 13, when you're given a value with an equation, you can do one of two things. You can solve for x, or you can just substitute x in right away. So I'm going to solve for x just to practice solving. So we can subtract 9 from both sides, and we get negative 4x is less than or equal to 27. And then we're going to divide by negative 4. And when we divide by negative 4, we have to flip our inequality sign, so it's now greater than or equal to. So x is greater than or equal to negative 27 over 4. Or if we want to put that in a decimal for our comparing, we would have x is greater than or equal to 6.75. X is greater than or equal to negative 6.75. So when I substitute 5 in for x, I would have 5 is greater than or equal to negative 6.75. And because negative 5 is closer to 0, it is greater. So this would be yes, negative 5 is a solution. The other thing that you could do is you could just substitute negative 5 in for x right away. And you would get negative 4 times 5 plus 9, which is 29, which is less than or equal to 36. So either way will work in trying to figure out if it's a solution. 14 and 15. Is x equals negative 1 a solution? So would x equals negative 1 fall in the shaded area somewhere? So in this case, Negative 1 would be somewhere to the right of 1, which is over by the shaded part of our graph. So we would say, yes, negative 1 is a solution. 15. Is x equals 7 a solution? Well, at 7, it's an open circle, and when we have open circles, we're not including that number because the inequality in this case would be x is less than 7, and if the number is 7, it can't be less than 7, so this is not a solution. In 16 and 17, we need to solve for the variable first. So in 16, I would distribute 2, and I get 4m plus 8 is less than or equal to 2m minus 12. I would subtract 2m from both sides, so 2m plus 8 is less than or equal to negative 12. I would subtract 8 from both sides, so I get 2m is less than or equal to negative 20. And when I divide, m is less than or equal to negative 10. So when I graph on my inequality, I have negative 10. I'm going to put 0 somewhere to the right of it. And at negative 10, it gets a closed circle because it's less than or equal to and shaded to the left. So is 0 a solution to the inequality? No. And how do we know? It is not in the shaded region. Number 17, when I solve for x, I have negative 4x plus 60 is greater than negative 2x minus 4 minus 10. So I can combine like terms. Negative 4x plus 60 is greater than negative 2x minus 14. I can add 2x to both sides. Negative 2x plus 60 is greater than negative 14. When I subtract 60 from both sides, I get negative 2x is greater than negative 74. When I divide by negative 2, remember yesterday, when we divide by a negative number, we have to flip our inequality signs. We have x is less than 37. So on our number line, we would have 0 somewhere on the left, 37, which is bigger than 0, and we have x is less than 37. So it's an open dot at 37, shading to the left. So is x equals 3 a solution? Well, x would be equals 3 would be somewhere over here, which is technically in our shaded region. So we would say yes. How do you know? It is in the shaded region.